All right, kiddos, hope you're doing well. Here are the two problems we looked at in class today. Most of you got to at least close to a solution for both, and if you want to know how I would solve them, here you go. So let's look at the first one. 10:30 a.m. Two planes are leaving, traveling in opposite directions, one a little faster than the other. Right? The question is, when will they be 2,100 kilometers apart? Right? So I'm going to start with a diagram, and it's kind of hard to do, but one plane's going that way. All right, that's where they leave from, and the other plane's going this way. Right, so we have a plane flying this way. That way, they're leaving at the same time. Right. The question is, when is this total distance 2,100 kilometers? Right. So the question really, if I'm going to start by framing this, so I'm going to start with the abstract. Right. I'm going to call this the plane that the west traveling plane. I'm going to call that distance d1. And the east traveling plane, I'm going to call D2, right? So for me, the way I would frame this problem, right, is at what moment in time will this distance plus the second distance equal 2,100 kilometers, okay? That, to me, is the framing, right? When is the distance the plane traveling to the left, plus the distance the plane is traveling to the right? When will that distance total 2,100? Okay, fair enough. So there's my frame. So let's fill that frame in. So what do I know, right? Well, of course I know that 2,100 is going to be the whole distance from here to there, right? What I also know are their rates, right? So I know the rates at which each plane is traveling, right? And I know this rate is equal to, let's see, that's one going west. That's 640 kilometers per hour. That's the rate. And I know the plane traveling eastbound. I know that rate as well, right? So I know this rate equals 560 kilometers per hour. Fair enough? Now, I don't know anything about distances. I'm trying to figure out when their total distance is $2,100. But I do know something about their rates, and I'm trying to solve for time t. So instead of thinking in terms of distances, I'm going to think of terms of r rate times t time, right? So each of these d1s and d2s I'm going to replace with rate times time, right? So instead of distance, I'm going to think rate times time, which equals distance. And then the other rate times time for the other distance, right? So the question is, well, how can I fill this in? Well, I'm going to first start with my variable. Let t be the number of hours, right? So t's hours, okay? So the first plane is flying 640 kilometers per hour. So therefore, the distance it travels, rate times time, is going to be 640 rate times time, right? Plus, because both planes left at the same time, this plane traveling eastbound is the same time. It's traveling for the same t that I declared here, right? Those t's are all the same because they're leaving at the same time, right? So the distance this plane travels, rate times time, equals its rate, which is 560 kilometers per hour, times the same number of hours, t, as the first plane. Okay. So there's my setup, right? So I framed it. I filled that frame in with detail, letting my t be the number of hours, declaring my variable. I used what I know. And now I'm ready to solve for t. Right? So now I can combine those to be 640 plus 560. What's that going to be? 1200. Right? So that becomes 1200 t equals 2100. And so now to solve for t, I divide both sides by 1200, and so 2100, the right hand side, divided by 1200 will be 1.75. So that's 1.75. So 1 3/4 and my label is hours. Okay, so let's solve the problem. That's how long it takes for them to be 2,100 kilometers apart. 3/4 of an hour. Well, a quarter of an hour is 15 minutes, so 3/4 of an hour is 45 minutes. So 1 hour and 45 minutes. I'll change that. Is how long it takes for them to become 2,100 kilometers apart. And so now I just have to take into account this 1030, right? Up until now, that 1030 was irrelevant. The only reason I needed it is now to answer the final question. So I'm going to add an hour and 45 minutes to 11:30. And let's see, that's 11:45. Nope. Let's say 2 hours will be 12:30. Subtract 15 minutes, 12:15, right? So I'm going to take this hour 45 minutes. They're both traveling for the same time. I'm going to add that to their starting time, and I get 12:15. So at 12:15, the planes are 2,100 kilometers apart. Solution. Okay? That's the first one. How about the second one? Now the second one's a little trickier because these two planes are flying in the same direction, right? So one of the planes, and they're both leaving at different times too, right? So one, here's my slow plane, and that plane's rate is 180 miles per hour, right? An hour later, that's important, right? So that means that this faster plane is traveling for 1 less hour at 450 miles per hour. And the question is, at what time will the jet catch up? In other words, when will their distances be the same, right? So when this fast plane, which leaves an hour after this, finally catches up, right? So the framing is as such. When, in other words, after how many hours, will their distances be equal? So I should label, well, I'll call this D1. So the slow plane, the distance it travels, I'll call D1. And the fast plane, the distance it travels, I'll call D2, right? So when will D1 equal D2, right? That's the framing. And once again, I have information about the rates. I'm looking for time, and I don't really know anything about the distances. So I'm going to replace distance with its equivalent, rate times time. Okay? So let's consider how we replace this distance here by its equivalent rate, which we have, times time. Okay? So D1 is going to be replaced by 180 miles per hour times t, time. So my variable, let t be the number of hours traveled by the slow plane. Okay? This guy is a slow plane. Okay? So the distance the slow plane travels, I rewrite as rate, 180, times time, t, which I let be the hours that plane traveled. Okay? Question is, when will the two planes catch up? So when will this distance, d1, equal d2? So d2, I now have to rewrite in a similar fashion, right? As rate times time. So the second plane is traveling at a faster rate, namely 450 miles per hour. But it's not times the same t, right? Because they started at different times, right? In fact, the faster plane started 1 hour later, therefore will be traveling for 1 less hour than the slower plane, right? So instead of t for the slow one, the faster plane will be traveling, since it left an hour later, 1 less hour than the slow plane. Okay? So there's my equation. All right? Now I got to solve it. So 180t, I'm going to distribute on the right. 450t minus 450. Right, distributed the 450. Now I'm going to subtract 450t. So let's see, 180 minus 450t is negative. Oh my gosh, what, 270? Does that sound right? Yeah. Equals negative 450. Of course, I can multiply both sides by -1 and clear the negatives. I don't have to worry about that. Now I'm going to divide both sides by 270 to solve for t. So t equals 450 over 270. Let's see what that is. 450 divided by 270. Okay, I get 1 2/3. Whoops, 1 2/3. Give me the fraction. Okay. And that's my label hours. All right, so the question is, well, t, that's the time the slow plane traveled. Therefore, the time the fast plane traveled would be an hour less than that, which is 2/3 of an hour. So therefore, I'm going to add either 1 2/3 of an hour to noon, or I'm going to add 2/3 of an hour to 1 o'clock. It's the same thing. All right. So the only thing I want to consider now is what the heck is 2/3 of an hour? Well, 1/3 of an hour is 20 minutes. So 2/3 of an hour is 40 minutes. So 1 hour and 40 minutes. I'm going to convert. All right. So therefore, the slowest plane starts at noon and travels for 1 hour and 40 minutes. I'm going to add an hour and 40 minutes to its departure time, which was noon, to get 1:40. So my solution for this problem is that an hour and 40 minutes after the slow plane departs, which is the same as 40 minutes after the fast plane departs. So therefore at 1:40, the planes will quote-unquote meet. Solution. Okay? Hope this helps. Bye-bye.